Hi guys, welcome back to our second video report for the Short Range Mobile Autonomous Race Tracker. I'm Hudson.
I'm Tyler.
I'm Rick. And Martin.
Let's get started. So I've been working on the power management side of this project, and so what we need is a battery that will be able to run these devices prior to the startup of any vehicle that would later power the device. And so what we need is a fuel gauge that will determine the remaining state of charge on the battery. Then we also need another IC that will determine whether or not the battery should be in a charged or discharged mode, and then a MOSFET that will help switch that. So in the bottom left-hand corner of the screen, what we have is an eval kit for that fuel gauge. And if we continue further up, we have a potential battery we might be using for this as well. It's a single-cell lithium-ion battery. And then we have a schematic up there at the top right-hand corner that will detail a little more information in terms of what we need to do to put this project together. Additionally, we need power filtration on the system as well, so to make sure we don't have any spikes on our supply rails. And I'll turn it over to Tyler.
So far, what I've done since the last progress update video was actually get two of these transceivers that we got, the SX1272 chips, to talk to each other, just sending simple text strings so that we could show that they actually will communicate and we could talk to them. Here's the actual transceiver and the antenna. When I was testing, I wasn't getting very good range, so I used a network analyzer to try and figure out what was wrong with it. So basically, this is the plot of the return loss. We had terrible return loss, and our 50 ohm impedance matching was not even close to where it should have been. So that should be the reason for our range problems. These were just off-the-shelf parts that apparently were not what they were supposed to be. So, but oh well. The next thing I did was I actually ordered an evaluation board for a processor that I want to use for the mobile vehicle units. This is actually the processor. It's actually an ARM M4 processor. It's a 32-bit chip with 512K of storage and 170K of RAM. So it should do the trick for everything that we need to do. So.
Since the last video I've been working on is the MAC protocol that we're going to be using for the device. Right now I'm settling on CSMA, which is carrier sense. A lot of Wi-Fi's use that protocol. The flowchart on the right is basically a real broken down, simple CSMA setup where it just listens to the channel. If it's anybody's talking, it'll back off. If it's quiet, then it'll actually start sending its transmission, or actually send a transmission to see if the receiver or the base station is listening. Once it gets feedback, then it'll send it all through. But what's important is you got to set that back off time, and that's what we're going to go with. As far as the bullets on the left, that's what I'm working on right now. Pending tasks are how we're going to code all this and how we're going to get it to implement with multiple units and see the probability of success is what's really important. The probability of success is what's going to determine whether we stick with this scheme or possibly switch gears and go with another.
Alright, so since the last video, I've done some research on Bluetooth stuff, which is mainly base station, since that how we connect to the end user interface. So we got a couple of Bluetooth technologies. We decided to go with the BLE, which is low energy, or it's really low power consumption, and longer range. So now we're looking into possible Bluetooth modules that we can use for testing and developing code for iOS devices.